Hi everyone, let's talk about the remainder and factor theorems for polynomials. We're going to start off with the polynomial f with coefficients in the field capital F, and capital F can be anything like the rational numbers or the real numbers or the complex numbers. You can safely assume that it's one of these three. And what we're going to be exploring is what happens if we divide by a linear factor or linear polynomial ax minus b, where a and b are elements of the field F. Then by Euclidean division, what happens is that f of x is equal to ax minus b times q of x plus r of x, where q of x is the quotient and r of x is the remainder. Euclidean division implies that a unique quotient and remainder exists such that the degree of r of x has to be less than the degree of ax minus b, which is the divisor. And that is equal to 1, which implies that degree of r of x is less than or equal to 0, and that means rx is a constant. It could be 0, it could be non-zero, but either way it's a constant. So what that tells us then is that f of x equals to ax minus b times q of x plus some constant remainder r. And if we substitute in b over a, then this term disappears. That causes the quotient to disappear, and we're left with just the remainder. And that's what the remainder theorem says. The remainder theorem says that if you divide f by a linear factor ax minus b, then the remainder is a constant, which is f of b over a. And you don't have to have a coefficient of the linear term a. You could just do f divided by x minus some c, in which case the remainder is f of c. And that's actually the usual form in which the remainder theorem is stated. I just happen to give you a more general form where there's a coefficient of a on x. Now, there is an important implication of this, which is called the factor theorem. And this has to do with when the remainder is 0. So what it states is that when you have f divided by x minus c, then that has no remainder if and only if c is a root of f. And we can see this is immediately true from the remainder theorem, because the first part is true if and only if f of c is equal to 0, since the remainder is f of c, according to the remainder theorem. And c is a root of f if and only if f of c is equal to 0. So this is the common aspect of both of them, and we then see that this is true. The factor theorem is true. Okay, thank you for watching, and I'll see you next time.